Okay, this video is for my geometry class. We have been talking about how to prove two triangles congruent, and we talked about the ways that you can prove that two triangles are congruent. And today in class we talked about two ways that are not legitimate ways, or two theorems that are not legitimate, or non-congruence theorems. And our two theorems that were not are AAA, which stands for angle, 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 and SSA, which stands for side, side angle. And we didn't get to finish why these are non-congruence theorems, but in general, or basically, and there's different ways you could word this, but for angle, 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 it's because you can draw two triangles of different sizes that have congruent angles. We talked about this in class. You can draw an infinite number of triangles that have the same angle measures. So if you told me that two triangles had the same angle measures, that doesn't tell me that they are congruent. They're similar, which we will talk about later on in the year, but they're not necessarily congruent. Also, side-side angle, which is the same, there's the same reason that doesn't work. You can draw two triangles of different sizes that have two congruent sides and a congruent angle, and they not be congruent. Or if they are different sizes, they wouldn't be congruent by definition. So I'm going to go to a video where I think a teacher does a good job of explaining it. Sometimes it helps to hear something different, or hear a different voice rather. So I'm going to go to this video and watch how he explains it.
If two triangles are congruent, there are 4 shortcuts that will work. Because there's 6 corresponding parts, 3 angles and 3 sides, you don't need to know all of them. We said if you know that 3 sides of one triangle are congruent to 3 sides of another triangle, they have to be congruent. The same is true for side, side, angle, side, angle, and angle, angle, side. The reason why these work is because if I give you 3 sides that are congruent, there's only one triangle that you can construct. But there's a darker, seedier side of geometry that we don't like to talk about. And that's the 2 that don't work. So let's take a look at the first one, which is side, side, angle. Now, part of the reason why this is the seedier side of geometry is because if you switch around the A, you got a square root, but I'm not going to give you the gratitude of hearing me say that. If we start off with this angle and a side, so I'm going to say this is a fixed angle, and this is a side that's rigid. Notice that I drew a ray here, and I'm saying that we need to make a triangle here, and I'm going to say that this point right here is the center of a circle. So it's going to be about a radius of my marker, and I'm going to draw it in dotted lines. And again, I am not an artist. So if we have this circle that is centered at that point, notice that using a radius, I can construct 2 different lines that are congruent. So I'm not changing that third side, but these 2 triangles are definitely not congruent.
That goes back to what we were talking about in class today. Obviously this is not a good circle that he drew, but the concept remains the same. That if you have a circle, one of the properties of a circle is that center point is the same distance from the circle. Let me word that differently. If you draw a line from the center point to the edge of the circle, the outside of the circle, every one of them is going to be equal. So that's the concept that is going on right here.
To redraw them, we have this obtuse triangle here. So we have these angles as being congruent. We have this side being congruent. And we have this third side that I haven't marked. So we have 1, 2, 3. So we have side, side, angle. And then this other larger triangle that I was able to draw, where we have these 2 angles being congruent, because I kept that fixed. This side was fixed, so these 2 sides must be congruent. And this third side, because it's a radius of this circle, this side must also be congruent. But notice we've created 2 triangles that are not necessarily congruent, which is why side, side, angle is not a shortcut. The second shortcut that doesn't work is angle, angle, angle. couple different ways to look at this one. One way is to say, well, if we were to extend that side, and if we were to extend this side, I could construct a line that is parallel to this side right here. And what I've done is I've created corresponding and congruent angles because we have two parallel lines, and this is a transversal, and this side is also transversal. And this third angle here would have to be congruent to itself.
Had to pause it there to had the student come to the door, but we are continue on with this video. I think you might have missed a couple seconds of this video, so let me go back here.
This is a transversal, and this side is also transversal. And this third angle here would have to be congruent to itself. So to redraw this, we have two triangles where the three angles are corresponding, but they are definitely not congruent. So we have a little bit of overlap here, but
when he says the angles are corresponding, the angles are congruent, but what he's saying is even though the angles are congruent, we have two triangles that are obviously not congruent.
idea is that these two triangles are definitely not congruent, but their angles are all corresponding and congruent. The word that we would use for these is similar. But this is not what we're talking about right now, because right now we're saying congruence. These two triangles must be exactly identical. So the two shortcuts that don't work, angle, 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 because we'll create two triangles. They'll have different sizes, although they'll have the same angles. And the second one that doesn't work is side, side, angle. Not only because it's a swear word, but also because we can create two different triangles.
Okay, so it's a very difficult concept when you talk about these non-congruence theorems, but it's something you need to start trying to understand. So hopefully that video helped. In class I try to explain it. It's a difficult thing to explain, but we'll keep working on it. And matter of fact, actually we're going to stop working on it for the time being and come back to it later on. So we're going to take a break from it. Tomorrow, just if you want a preview, we're actually going to look at these two diagrams, and I want you to think about these questions that are posed on these diagrams. I'm actually going to give you these diagrams. You're going to put them in your notebook, and I want to know, first of all, what type of angles are the 110 angles here. So we have this angle here and this angle here. What types of angles are those? And based on those angles, what can we conclude about line segments AB and CD? Now in the second diagram, what types of angles are 60 and 70? And based on those angles, what can we conclude about EF and GH? So think about that before you come to class, if you happen to watch this video. That'd be a good thing. Then based on that last thing I talked about right here, we're going to look at the problem from last year's readings exam. And you're given information here, and we actually got that on Friday. And I actually made a diagram that is similar to what you see actually in this problem, except I just took, I have the I here, take that away. I want you guys to recognize that this is just two lines cut by a transversal. We talked about that. And if we know that EGB, which EGB would be right here, if we know that that's 50 degrees, and that DIG, so DIG, well, I'd have to put this here to do my DIG. So DIG would be right here. That's going to be 115 degrees. And what do we know? Explain why AB is parallel to CD. Well, let's go back up into our given information. It says that EF, so EF intersects AB and CD such that, okay, at G and H respectively, and GI is drawn, so GI is drawn such that GH is congruent to IH. Alright, so we could actually write that in our diagram that GH is congruent to IH. Now I want you to think about what type of triangle is GHI. Think about that for a second. Okay, I'm back now. Hopefully you recognize that GHI is an isosceles triangle. And if it is an isosceles triangle, that means that these base angles, the angles opposite these sides that are congruent, are also congruent. So we don't know the angle. Well, let me move this right here. That'd actually be better now, wouldn't it? So that's 115. And we know that these angles have to be congruent. And we know that this angle HIG and DIG are supplementary, so they make 180. They combine, the sum of them is 180. So that means this one must be 65. So this must be 65 degrees. And if these are equal, these angles, they have to be, then that means up here is also 65. So this is 65 degrees. And let's see, if these three angles now, this one, and then this one here, and this one have to add to 180 because they make a straight line. So that means that this angle, if you have 50 plus 65 is 115, and then this out here must be 65 also. So 65, 65, and 50, these three add up to 180, which is what we are looking for. And I know then this triangle is 180 degrees, the interior has to be, every triangle. So if this is 65 and this is 65, then this must be 50. Alright, so now, if I had these same, now it's asking to explain why AB is parallel to CD. Well, since these angles, GHI and EGB, these are corresponding angles. Since they are congruent, that proves that these lines must be parallel. And hopefully after we do the exercise in class, that'll become more apparent to you. So hopefully you watch this and get some understanding. We're going to go over this in class tomorrow also.